And they give an example in the book. Oh yeah, that's right. There's no matrix here yet. Yeah. We did an example in class. Let me see. I'll do 43. Just so I don't do the homework for you. This is 43, section 9.1. Alright, so I got my 1, 2, 3. We might have done this one, I can't remember. Did we do this one? No? Yes? You're all like, dude, that was like last week. What do you want from me? Alright, anyway, we'll do it again. Does anybody notice something interesting? Sure, okay. Alright, so we'll go with that. First thing somebody said, I'll go with that. So if you add, so the nice thing is if I add 2 to 1 and 3, it'll kill the y's there, right? Mm-hmm. So if I add 2 to 1, what do I get? 2x plus 2z equals 8. And if I add 2 to 3, so this is the fourth equation here. Oh, sorry.
3x.
3x
Plus 3z.
plus 3z. 12. So now these two are my fourth and fifth equations. They're better than any of the other equations because there's less stuff that I don't know. I'm closer to knowing something. Right? Somebody notice I don't have to multiply by 3 and 2 and all that kind of crap because what can I do with that one, for example? Yeah, divide by 2. So the fourth equation now, x plus z equals 4. And this one I can divide by 3. So the fifth equation now is x plus z equals 4. So if I multiply this one by a negative, for example, when I get 0 equals 0. Yes, and that's if I get to that point, that will always tell me there's an infinite number of solutions. If it's just a single variable equation, my answer would be all real numbers. Here, that's not good enough, because my answers are points. You can't just say all real points. No, they're specific points. So if I know that x plus z is 4, let me see, where can I go? What is it that so like for example, on this one I can say x is 4 minus z. Is that cool? Mm-hmm. Yeah. And z is z. Is that cool? Because does z have to be something? No, z could be anything it wants to be. But the minute I let z be something, then x has to be 4 minus that. If z is 2, what's x got to be to make this true? Negative 2. 2. 2 plus 2 is 4. If z is 1, what's x got to be? 3. If z is negative 5, what's x got to be? 9. I love it. So the fact that these two cancel each other says there's no restriction on one of these variables. So I said let me let z be anything it wants to be. Z is be your own self. Do your thing. Do you, z, right? But the minute z is something, that means x has to be something specific because together they're supposed to make 4. So that's what happens when I get 0 equals 0. That's no restriction on some variable. But then I go back one. Oh shit, if z is anything it wants to be, now x has to be 4 minus z. I'm still doing the domino thing. I don't know if you guys get what I mean when I say that. I got here, I go back one. Now I got x and z. How do we get what y is? Go back to these. So in the first one, what's x? What's x? 4 minus z. What's y? I don't know. What's z? Z. So what's this say now? What happens here?
We cancel out.
Good. So you go y is 1. Yeah, we did this one, I remember now. This is basically the way it always works. The z's have to cancel out in general? No, they could still be there.
So once you figure out 0 equals 0 at the end,
Then you go back.
you're plugging anyone in for either.
Yeah, you pick. I could have said x is x, and then z would have been 4 minus x. It doesn't matter which one. One of them can be anything it wants
You
to
have
be.
to pick 4 or 5.
Yeah, exactly. Yeah,
Or you
Which
get
is the same thing.
same thing. Second?
negative x plus.
Oh, I multiplied by -1.
Okay.
Yeah. So this could have been like 1 plus z if there would have been an extra z or something. The z's don't have to cancel, but now I can say, what's the point? The point is x, y, z. Well, what's x?
4 minus z.
4 minus z. And then what's y?
1.
1. And what's z? Z. So any point that looks like that will work here.
Can you have something like y equals 1 minus 2z? Something like that?
Yeah, totally. Yeah. Took me a second to catch up to you. Here the z's just happen to cancel. They don't have to.
But I mean, can you have, like, it doesn't have to be just 1z, it can be like
Totally,
y,
yeah.
or like x.
Exactly.
Or
So another way that this could happen, if you get 0 equals 0, my answer could be something like 4 minus 3y, y, and then y plus 2. That could be an answer.
Okay.
Y can be whatever it wants to be, but then z has to be this, and x has to be this.
Okay.
So what does this really define? How many variables are there in this?
3.
1.
1. Why? I know it's an x coordinate, a y coordinate, a z coordinate, but how many variables do I need to define these points? 1. So this is a line. This is a line. Do I really have to understand that right now? No, but that's the geometry behind this. This is a line. So for example, give me an equation of a line. Y equals mx plus b. So 2x minus 7. I love it. That's a line. How many variables define that line? 1. X. I know there's 2 there, but when I plot what defines my y, it just depends on x. So all my points, whatever x is, y has to be 2x minus 7. Holy shit, that is what a two-dimensional collection of points that make a line look like. Doesn't that look like this? Doesn't that look like this? Just in 3 dimensions now? I know I'm blowing your mind. I only put a couple of these problems in there. But this is when you have 2 planes, or 3, I should have brought something with me. So if they all meet at a line, so can you imagine if this plane and this plane, they meet at my finger here, that's the line, and they have another plane, and they also meet at that finger. So the answer is going to be my finger. It's a line, the spine of it. And that's going to be a line, isn't it? So it should be able to be defined in 1 variable, like this. That's the line, that's the spine of all the meeting planes. That's neat. That's the geometric interpretation. Okay, maybe. It's enough of that. It's enough.
So if you had like 500 equations, you'd open up a book.
Totally. I love it. Exactly. I mean, I'm being stupid. I got a perfect example right here. Yeah. Those 3 planes meet at the spine of the book. The spine of the book is a line. The definition of it could look something like this. So, just to make the point I made last time with this, somebody give me, what can Z be?
5.
I love it. Anything it wants to be. So it could be 5. If Z is 5, that's always 1. What's X? Alright, so what should be true about this point? So on the line, and what's that line do? So that point should work in all of these. Let's try it. -1 plus 1 plus 5 is 5. Check. -1 minus 1 is -2 plus 5 is, holy shit. So any number you pick for Z, as long as you make X 4 minus that, the point you end up with works. So just saying infinite number of solutions, not good enough. I want to know, what do the solutions look like? That's the point. When you get 0 equals 0, this is the kind of thing you have to do. And they do have some examples in the book that show you how to go through that. All right, that's enough of that. That's enough of that. Obviously not a huge deal right now, but I desperately want to see if some of you guys can latch onto this and understand at least how to get the answer written, if not fully understand what it means geometrically. But that's beautiful. It makes a book. So yeah, we have... Any of you guys ever heard of Pandora? If you come to my office, I'm always playing Pandora. I love Pandora. Pandora takes like a jazz song or a blues song. They define it using like 400 variables. So some of the variables could be how prominent the vocals are, how much percussion instruments are used, how many different types of instruments are used, so forth. I mean, just if you're a musician, you know how many different ways you can describe a song. Any musicians out there? All right, sort of like wine. The more you know wine, the more it's fruity with a little hint of, I don't know wine. It's good wine, but right. But the more you know something, the more you can define it. So there's 400 variables, 400 ways to measure a song. So Pandora says, "Oh, you like this song? Well, then it looks at it like the line of all the variables." And then it says, well, this song is really close to your line, so I'm going to play it and see if you like that one too. If you don't like it, I must have went the wrong direction. Let me go a different direction and give you another song. If you like that one, I'm like, oh, cool, you like this kind of area. So let me give you more songs in that area. It's neat. It is 400-dimensional space, but let's not think about that. It's very difficult to think of 400-dimensional space. Let's not. All right, I'm sorry. I just love that Pandora uses that. All right, I'll stop. Anything else, some homework that I can go way too far on? Anything else, some homework? What was that I was asking you? Remind me about something. Wasn't I? No? Shit. I thought somebody asked to remind me about something. Oh well.
34, 914. I was only 2 pages and trying to simplify this.
Oh. Scheisse. All right. Let's do the first couple steps for this problem. Let me say this. Whenever you write a matrix, look at the book and write a matrix, check that 3 times at least. Because all it takes is one missing negative, or you wrote a 2 instead of a 3, and the whole thing is shit. Everything you do after that is wasted time because you're not doing the right problem. Do you guys understand what I'm saying? Triple check it when you copy it over. My God, because that's all it takes. Is a 1 becomes a negative 1, the whole thing is shit. Which one was it again?
34.
34. 10? Yeah. See, right there. Man. Does anybody notice something about the very first equation? Yeah, I could divide it by 2, right? I'm going to do it right now. Before I do any matrix stuff, I'm just going to divide both sides of the first equation by 2. So now the first equation becomes...
Minus 2 plus d equals 5.
I like it. So that's the one I'm going to use in my matrix. So take a minute and write the matrix down. Write the matrix down for these equations. What are you doing math, honey?
Talking about the matrix. There is no spin.
So tell me, what's the first row look like?
1, negative 4, 1, negative 3, 1.
Okay. That, right? 1, negative 2, 1, 5. So very cool. There's some 4s in there, it's no good. Second row?
Negative 1, 3, negative 4, negative 9.
Thank you. And then the third row?
2, negative 1, negative 1, negative 6, negative 8.
Cool. So that. Okay, cool. Even if you didn't notice, you could divide by 2. I mean, right here, you would multiply this by negative 2 and kill it, right? But what's really nice now is how can I know my goal is this, right? That's my goal. And it's okay if these are out of order because I can just put them in order or not, depending on how I feel. What's really important is that you get these zeros. So how can I make a 0 right there?
Add 1 and 2.
Yeah, add the first row to the second row. And put the answer where? Put the answer where?
So the second row.
Yeah, the second row. I like it. So if I do that, I get
1,
get 0,
negative 3,
1, negative 3,
and negative 14.
and then negative 14. What's up? Is there we are?
No.
And then I can kill this one. And what's interesting is, how do I kill this? Make a 0 here. Yeah, I can multiply this by negative 2, or I can multiply this one by 2. It's already different signs. Because right here, it's still there. It's still there right there. I don't know if you guys see what I'm saying. Doesn't matter how you make a 0. You don't have to use this one to make a 0. Or you can use whatever. So if I multiply the second row by 2, and add it, what do I get? I get 0, 5,
2, 14.
negative 14. Good. And the first row can stay the same. I know all too well, not only because this always happens, but also I can see it in a lot of your eyes that you hate matrices. Why do I need to know them? Screw matrices, blah, blah, blah. You're just getting used to them, that's all. Right? And once you get used to them, you can do a lot of this quicker. That's one little shortcut, is doing 2 things at once, so I don't rewrite the matrix twice as much as I need to. Yes? Yeah? You want that done? She's okay. Yeah. Alright. Let's see. Blah, blah, blah. And now you just keep going. What's nice about that matrix where I am now, that it's not always going to happen?
The second row.
Already has 1.
I've already got the 1. If I didn't have the 1, I don't have to make it 1. If it was a 2, I could add it to this and kill it. So please, dear God, if that's like a 2, don't divide by 2 and make a bunch of fractions that you don't need. 1s are not as important as 0s. Yes, sir.
So are we going to multiply both of them to make it like a negative 10 and 10? Or...
No. All right. One thing about what you just said, I could not use this to kill this. Do you see what I'm saying? But are you saying if this was a 2?
No.
Or are you saying about the way it is right now? I cannot use...
Multiply the left and right side of the first equation. And then you multiply the left and right side of the bottom equation by a different number. And then you have a like thing to cancel each other out.
Sure. You could kill this -2 by doing that.
Getting 2 zeros.
No, because you don't replace both of them. You only replace one.
Alright, so you
Yeah,
just replace one
I like it.
with two.
I like it. So there's a 1 in the middle. I'm going to use the hell out of that. If there's a 1 somewhere, I'm like, oh, okay, good. Everything's a little easier. I can use that. I can multiply by what to kill this?
2.
2. And multiply by what to kill this?
-5.
-5. Kick ass. And you just keep going. I don't know if I hit.
Yeah.
I probably did it a different way than you did,
No, it's fine.
right?
And should we like all of those steps, like, because if you know like anything like that?
You gotta tell me. Yeah, I didn't show that step, did I? Because I did it here. But yeah, negative. What do we do? Twice row 2 plus row 3. So row 3. Give me some sign of what you're doing. Because like I was telling somebody earlier, if you don't tell me what you did and you make a mistake, I have to assume the worst because I don't know what happened. It could have been a really simple little mistake that you wouldn't lose many points on. But if you don't show me work, I've got to assume the worst. Because I don't know.
We have to like divide, add, subtract.
Everything you can do with
Just
equations.
at the table, like it.
Everything you can do with equations, you can do with the rows of a matrix because that's what they are. They're equations. I like it. Alright. Good. We start off in a good place to oppress you immediately. You've got to squeeze that hope out of you early. Good. Even that get the reaction from you. Alright. Hope crushed. Good. Anything else from homework? That can crush your hope more? Your dreams? That's what math people do. No? Everything else is good in homework? Okay. Oh, that's what it was. Should I do that right now? How many guys have like a registration date today or coming soon? Or how many guys are curious about what to take next semester? All right. How many guys know exactly what you're taking next semester? Have no problem. Okay. All right. So some of you guys are in here, this class because you need to take pre-calculus. How many guys need to take pre-calc next? All right. Some of you guys are in 110 because you're like 103 or 110. You just flipped a coin. You took 110. How many guys have to take stats next? Anybody? Stats. 120. Anybody taking 120? 120? Okay. Depends on your major, right? All right. I was going to look at the next semester. It looks like very few of you need any help. So you can see me in the office if you want to talk about what to take next semester.
What's 175?
So 176 is 170 and 175 combined. You guys kind of with me? So if you have to take pre-calculus, 176 has trig in it. 170 is trig and 175 is, pre-calculus. College algebra is what they call it. But if you put those together, you get 176. So you could take 176, or you could take 170 and 175 separate.
Is that right? 6 units?
Yes. Cool. And you'll notice if you add 170 and 175, you get 7 units. Or you can take 176 and do it in 6 units. But 176 is pretty intense. Right? It's 6 units, and people don't sometimes budget enough. That's like 2 normal classes. Are you with me? So you have to have twice the amount of time set aside for homework if you take that. But the nice thing is you get through it quicker. You have to pay a little bit less because it's 1 credit unit, 1 credit less.
So if I were to take 175, I'd take 170 after that? Or
Yes.
175 and then take 170?
Either way. But I would recommend you take 175 and then take 170. It's kind of unfortunate. 175 has all the algebra in it. 170 has all the trigonometry in it. So if you take 170 and the next semester you take 175, the algebra will have leaked out your brain, right? Now you can do both in one semester, but those people don't really understand too well because you might as well take 176 then, right? If you have to take 176, did that make sense? What I just said? Everybody cool with that? If you don't, it doesn't matter. Right? Okay. 160, I'm teaching on 160, but part of the course is linked with an English course. It's like for the freshman academy, something or other. I'll probably be able to take a lot of people from my wait list, though, into the stats class because I don't think the English side is going to fill up. So I could probably take some people from my wait list.
Do you have to be in 120? Because I'm going to be in 124 next semester.
Oh, you're doing 124 or 125?
124.
Oh, do we teach at 124?
Yeah.
Really? What is it?
Advanced English.
Oh, I'm sorry. English. I don't think about English. All right. The 160 class is only linked with 120.
Okay.
There's a certain professor that I'm working with that we're making some assignments that students will take their data from my stats class and they'll write papers about it in the English class. Do you see? So the people that are in my stats class aren't missing out on anything. It's just that some people do a little bit more with it and get credit for English at the same time. It's not a bad deal. Anyway, so if you have to take English 120, you might want to consider, and you have to take stats, this might not be a bad option. Plus, I use a free textbook for my stats class. It's a one-line textbook that you can just get the PDF for and look at it. Yes?
What's the name of that class again?
Statistics.
The one that you're teaching that's combined with...
Yes, it's just one of the sections of statistics is linked with an English class. My section of stats, yeah. All right. Any other questions about courses for next semester? Yeah.
So you do 120 or 175, like I was wondering, it's two different directions, obviously.
Yes. If you got to take 175, you would never take 120. Although I wish everybody had to take 120. Because in 120 I teach like Egyptian hieroglyphic numbers, Fibonacci sequence, the connection between math and art, and math and music, and math and anything. So I love that class. I do. But yeah, you don't have to, if you're going to take math 175, there's no reason to take 120 except it's really freaking cool. And not everybody agrees with me about that. So I understand. Anything else about next semester?
So what, one more, sorry.
Sure.
170 is calculus, or what is it, 170?
170 is trigonometry. Yeah. Sine waves. You've all seen sine waves on the oscilloscopes in horror movies and stuff in the background in some mad scientist lab. So there's a function that describes this periodic motion. There's sines and cosines, and then you got tangents and all that kind of shit. It's what they use in surveyors go out there and they calculate angles between things and so forth. They use trigonometry, or their machinery does, but they have to know it too at the same time. Anyway. All right. I'm trying to bore you in an entirely different way today. You're doing good, Jeff. All right. So let's get back to the math. Anything left over before I get into chapter 10? Anything from chapter 9 left over?
So that's the answer right there then?
No, definitely not. I just said I would do the first couple steps.
Okay.
But now, you know what to do next. And double it, multiply by -5, so you can get the zeros there. This is telling you what to do. And the less confident you are, the more you do, get this column to look like this. Get this column to look like this. And then you get this column to look like that. Yes?
Can you go over number 18 on 9-1?
And while I'm thinking about it, be very careful. I don't want to see any matrices in 9-1. And I only want to see matrices in 9-2, right? Those are completely different sections. Which one, 9-1? 18. Oh.
I mean, I know the substitution,
Yeah.
but I don't know what the rate.
So 18 is an example of a problem that I think it freaks people out because it doesn't look like what you were expecting. But anytime you have blanks, that's an awesome place to be. It's like somebody's already done some of the work for me. So what do I know for sure? What's a total known?
C is 3.
I know C is 3. So this is the domino thing. Now I can just fall back to this equation, replace this C with 3, solve for B. And then I'll know B and C. I can replace B and C and solve for
I know, it just came out like really ugly, so I don't know if it's the right way.
Oh yeah, you're going to get fractions. B is 2/5, right?
2/5, and then A is 3.64.
91/25. Sure.
What is it?
91/25. Yeah, so this is a really good problem to give you where fractions show up, because you don't have to use those fractions much, you just get them and you're done with it. Alright, so especially now at 110 level, you should realize that you're not going to get as many whole number answers as the past. We're getting closer to real life. And real life doesn't always have nice whole number answers. We know that all too well. Okay. Alright, so let's get into chapter 10. If you took 90, Math 90 recently, this is the last thing you should have talked about with some of the stuff from this chapter. We're obviously going to get a little deeper into stuff. Do some sections you didn't do there. But let me just start us off. I think we talked about this a little bit before. Just see what you guys remember. What's the square root of 81? That's great. What is the fourth root of 16? Why?
No.
Because 2 times 2 times 2 times 3 equals 16.
Yeah.
I like it. So the key with symbols in math, and roots aren't as bad, because you've known about roots for a while, so your brain already translates what this means. But when we get to stuff like logarithms, how many people have heard of logarithms? How many people are like,